We are going to try this out. Today you can already see this is a completely new setup because we are playing a completely different game. We are playing the Devil's Calculator. Let's try this one. I hope that the recording is going to work this time. I have tried some other things, whatever. We are going to try to play the Devil's Calculator, and what does this game do? We do have a normal calculator with the exception of this symbol. This symbol is a function. This function, if you use it on 0, this time is going to spit out 6. If we use it on 6, it's going to spit out 18. Alright. If we use it on, I don't know how to delete stuff, like this. If we use it on 1, it's going to spit out 8. So one reasonable assumption could be this function adds 2 to our total number pulled in. So let's just say clear. We want to use this one on the number 664. We get 1334. So the assumption we made before is not correct. We need to deduce what the function does by looking at what it does on different numbers. So we are going to use this function on the number 444. It's going to deduce 894. Okay. So first of all, the idea that I have is f of x equals what was it equals 6 plus x times 2. So in theory, if we just typed in f of 333, we would get the number 672. We need to get a number that, if we use this function on, equals 666. So another idea would be we are 6 off from our real number. So what if we use 630 as our number? It would equal 666 if our assumption is correct. So let's try it out. Okay. Oh. I am still not used to this. Okay. Function 330. Correct. Every time we get another function, and there's a story, but I don't care for the story. I have found this game by watching Aliens Rock, who's a YouTuber. He does really cool puzzle games, and I discovered him recently. So level 5. Now we are not allowed to use this 5, otherwise, or we will get an error, and our entire function will basically, we will get an error. Basically, that's it. So the goal is normally going to be, we're going to start off with a function and look what it does on our first few attempts on using it on a number. So we used 0, now we get an 11 out of it. We are going to use the function on 1, we get a 12 out of it. Okay, we are going to use our function on 3, and I'm assuming the first attempt would be that our function is, maybe I should increase, I'm going to zoom in a little bit. Can you properly see this? Yeah, okay. My first attempt would be thinking that this function is called 11 plus x. That's the first idea. So this should theoretically go for 14. Okay. We're going to do one more try, and then we're going to type it in. We're going to put in input a 10. So theoretically, f of 10 would be 21. What? Hello? 21. So it seems we get a tip. This symbol can be used many times in succession recursively, i.e. we can place it like this. That's fine. I just wanted to verify that my idea was correct. Now the idea is we are going to search for an x, f of x, so that f of x equals 666. What would that be? 11 plus x equals 666. That means x equals 655. Pretty simple for now. The problem, however, lies in the fact that if we type this in, we aren't allowed to use our 5. So we're going to search for a number so that f of x equals 655. And if you see the pattern, the number is going to be x equals 644 if we do this twice. So we're going to do the function of a function. We are basically doing f of f of x, and or x is going to be, in this case, 644, if I deduce things correctly. Okay. I have basically seen a lot of the levels before, but I didn't really look at them too intently in the video I watched, so I'm not actually being spoiled, I'm doing this the normal way. Level 6. I can also use the graphs view to help identify patterns in more obscure functions. So I can go to tools, welcome, This space is for note taking. I already have a better space, which is, I like this space more because it fills up the screen. This window is a calculator's window in size. And no, can I watch a calculus? I can also use a normal calculator that isn't cursed. The idea is that this calculator was cursed by the devil. I don't get it. Anyways, somehow you can also go for a graph view, but I don't know how. So for now we're not going to use it. Let's just continue with our ideas. And I'm also guaranteeing that the functions are going to be a little more complicated in the future. I think you saw it, but I haven't started at the 0 point, at level 0, I started at level 4. So I just wanted to get out of the way the things that really nobody cares about. Those were just the beginning functions. Okay, we can already see what a function is going to be. We're going to do a little bit of a table. So we're going to do it like this, a spreadsheet basically. But since I don't really have a spreadsheet site open, I just want to show what the function does. So we start off by 0, x equals 0, and f of x was also 0. F of 1 equals minus 2. What is f of 2 going to equal? There's already two options that we can go for. Either it's going to be minus 4, or it could be 4. Depending on which one it is, I already have an idea what it is going to be. I think we already know f of 2 is going to equal minus 4. So we already have a really good idea what the 3 is going to be. Minus 6, right? Where is f of 3? We can't use 3. So we're going to assume this is minus 6, and we're going to try out f of 4, which we are going to assume is going to be minus 8. And I already have an idea of what the function is going to be, since this isn't too complicated for now. The function basically is, where do I put it? F of x equals minus 2 times x. Pretty simple function. Yeah, I just had to think about whether this was correct. And now the big question is, what is what solves the equation f of x equals 666? Equals 666 equals minus 2 times x. Okay, we have all our functions open. How do you solve this equation? It's pretty simple, you divide by minus 2 on both sides. So we have minus 333 equals x. And as you can see, we can't use our 3, so very hot, it burns, such heat, very hot. Ouch. Yeah. So how are we going to do this? We need to search for a function that equals minus 333. So we're going to do this again. It's basically a recursive idea. F of x equals minus 333 and equals minus 2 times x. We're going to do the same thing we did last time, and times minus 2. Normally you should do, I think it's called parentheses, I'm not sure. Brackets, we're going to call them brackets for now. Again, I don't really do math in English, but hey, this is a good start. So, any ideas on what is going to come out? I mean, it's probably going to end with a 1. What about 160? What about 166? 332 is going to come out if you double this one. So if you have 166 times 5.5 times 2, it's going to equal 333. So equals x, and we're going to try it out. 166.5. I need to first put in this 166.5, and we have this. Now we need to do this twice. So our equation was correct. assuming we do have the function down pat, which is probable. The first few functions are pretty simple, and we're not going to have something too challenging. In this video, how long is the video already? 10 minutes. We can go for level 10. I think that's a good place to stop. Okay, same thing. The idea is simple. I'm going to delete the ideas we had until now, so that we have more space. And I'm actually going to go ahead and make this even bigger. I hope that the font size actually, yeah, I think we should be fine. Okay, so the function of 0 is 6. What is the function of 6? I'm too lazy to type in all the things. Okay, 18. What's the function of 18? 42. So we're going to do our basic table again. 0, 6, 18. F, and we have 6, we have 18, and we have 42. So what can we think about? Let's first start off. We could do more numbers, and this would make things a lot easier if we do more of the numbers, but for now I'm just going to try this out with a linear approach. The first few things are going to be linear. The approach is going to be m times x plus b. We already know b if this is a linear equation, a linear function. The idea is that b is going to be the number that that you get by inputting x equals 0. So f of 0 would be m times 0 is 0, plus b, and b is here is 6 in this case. So what is m times x plus 6 if you put in f of 6 equaling 6 times m plus 6, and that equals 18. So if you do the maths, which we're doing currently, you do need to subtract 6 from both sides, because in this equation you want to solve for m, and this equation doesn't have any m. So this, I could use this equivalency things. I don't know if you know the symbol. This means that whatever I'm writing here is equivalent to this equation. Nothing special for now. 6 times m equals, and what is 18 minus 6? What is 18 minus things, folks? What is it? 18 minus 6? Right, it's 12. Okay. I mean, sometimes, I don't know, probably not that many people that watch my videos do know that, since I'm a Yu-Gi-Oh player, and Yu-Gi-Oh players do not really know maths. Okay, I'm joking. I just like math, so we're going to do this. M equals 2. So the idea would be that we assume assumption. Oh, I don't know, assumption. I'm using Notepad++ by the way for this thing, so those were, who cares about that? Assumption or function equals 2 times x plus 6. First idea. So what would we need to go for? We can check. Now I'm going to keep my assumption for now. We do want to make this a little more exciting, so we are going to check for f of x equals 666. And that would mean 2x plus 6 equals 666. Didn't we already have this? I'm not sure. So this equation is equivalent to 2x equals 660, and this is equivalent to x equals 330. So I did minus 6, wait, from this to this minus 6, and from this to this divided by 2. Nothing too special. So x equals 330. We're going to do the thing we did again. We're going to think about f of x, basically, which I'm going to write as f of x equals 330. This is the same as solving, if we have this x, we can solve the equation f of x equals 666. Basically, if you think about this, f of x equals, if we have an x that solves this equation, f of x equals 330, this formula right here equals f of 330. And we already know that with x equals 330, this solves the equation f of x equals 666, so we get 666 as an equation. So what do we get if we use this? Which x do we get if we do this? I'm going to spare you the details. Nah, I'm going to do it. I don't want to do this with thinking too much. 2x equals 224, x equals 112, Again, I could make mistakes in between, so I don't know. Okay, well, 1 second. 100. Okay, 112. And we have a mistake. So what's the mistake? We are going to try, first of all, we're going to try 330. We can't try 330. We did make a mistake, and the question is, when did we make a mistake? So, first question, we're going to try out some more numbers. When in doubt, we can try out more numbers. This still looks like the function that I am expecting. It should be 2 times x plus 6. Right here you can see this. If you put in 1 for this x, it equals 2 times 1 plus 6 equals 8. So this still seems like the function, or maybe I just made some basic calculation error. 224, 2x. I mean, this seems to be correct, so I don't know. I would assume that this one would output 330. So why should it output 330? Okay, you didn't see this little mistake. Let's just say my eyesight isn't that good, and I don't know. I just thought this would... Okay, everything was correct. I was just making a mistake. Now we can't use a comma, or we can't invert our things with putting a minus in front of them. Alright. Let's delete or cache, or what is it called, history, and okay. So if you input 0, we get a minus 3. Alright. If we input 1, we get a minus 2. If we input 2, we get... If we input 2 into our function, we get minus 1. So x, f, 0, 1, 2, minus 1, minus 2, minus 3. What's the assumption that we have right now? The idea is probably going to be f of x equals minus 3 plus x. That's the idea. And if we think that, then we would assume that f of 663 equals 669 equals 666, which is probably not correct. We're going to try it anyways. 669, 336. So we did... Okay, we have this one. Oh, what? Okay, let me think about this. First of all, we're just going to continue off inputting a few more data sets. 0, okay. At what point do we expect this to fail? If we assume that this is algebraic, which we could fail, first of all we should check some of those numbers that I just wrote down, whether they are correct. I'm not going to check all of them. We're going to check V8, 5, okay. And that's basically, I don't care for the rest. I think that for low numbers from 0 to 9, everything is going to work out perfectly. However, I do think that we get a problem when going for 10. We're going to check 9 as well, just in case. 6, and now we're going to type it in 10. Function 10. Okay, minus 23, okay. And I have, okay, no, 0, yes, okay. So, minus 23. I want to try out 15. I already have an idea of what the function is going to be, but just test it. Minus 22. Now I'm confused. I would have... Oh, oops. 16. I wanted to type in minus 23. Okay, yes, so what does it do? First of all, minus 23, and if we type in 16, we also get a minus 23. What does that mean? It means that our function is first of all not algebraic. We can't type our function like this, but our function f of x equals, and now we need the function that we thought about. I'm going to write it in a complicated way. I'm going to write this as a g of x1, g of x2, and dot dot dot. What does it mean? Let's say our x is 122. This would mean that our x1 is 1, our x2 is 2, and our x3 is 3. It just means that we're going to look at each each number making up the whole number, and we're going to use our function g on that. I just had to think about the minus. The first number is going to be a normal g, but in the second numbers, and from then on, we need to make this around them. We need to make them do the abstract of them. I think that's what they're called. We are only allowing positive numbers. So let's think about what we would get if we just typed in 999. What would we get if we just typed in our function of 999? 666, since in each case we would get g of x, or g of 9 would be 6, so 666. That would be the goal of the idea of this. Okay, we are getting further and further, and this is our second to last level for today. And I'm going to go ahead and delete this part. Okay, level 9. 0. Okay. If it's algebraic, we know what this looks like. Okay, minus 82. This already looks dangerous. Okay. 2. Minus 6. Yeah, I think I do remember this from the stream. Yeah, okay. This is a little unfair because I do remember this. The help menu is different each level. Console it often. No. Okay, minus 80. So, what do we have? We have a 0. We have a minus 82. We have a minus 80. And we have a minus 6, if I'm correct. So, the idea is probably going to be f of x equals. And we have to make a distinction of x being odd or even. If our x is even, we have a different function for when it's not even. So that's the idea. We're going to think about this. So the first idea we could get from this could be we need, I'd say we need three more ideas in order to correctly pin down the function for now. So we can't do the 5, but we can't do the 4, but we can do the 5 and the 6, and the 7 also. I want to have those function places identified. 5, 78. Okay. All right. Yeah. I do think that I know what we need to do. So. Okay, so if you didn't notice, every time we have an odd number, we go down. The difference between 1 and 3 is 2. The difference between minus 82 and minus 80 is also plus 2. So we increase this number by 2 and get minus 80. So the idea for this is an odd number. For odd numbers is going to be plus 8. Plus x, I mean. Minus 82, minus 83 plus x. I think that this is the equation that solves this. If we input 5, we get minus 83 plus 5, which is minus 78, which I need to put the minus in front of this. Alright. And this probably solves the entire thing on odd numbers. What about even numbers? We have a minus 6, we can't see the 4, so we're going to check out the 6. That's a lot of talking. Minus 18, okay. Minus 18. I mean, if this is a 12, okay, I'm going to do an assumption. First of all, we already probably know that this is a minus 76, and I'm going to assume that this is going to equal minus 24. So, I'm going to input a 7, minus 76. Since I can't check the 8, I'm going to go further and I'm going to type in minus 74. And this is going to be a minus 30. Correct? Minus 30. I was correct. So each time we go down 2 numbers, we go up 2 numbers on the x scale. So if we have a graph, this is the x scale, and I can't really do the y scale properly, so we're going to do it like this. This might be the y scale. Every time we go up 1 number on the x scale, this one goes up. We're going to go up 1. How do I write this the best way? So x goes up by 1. We get a y increase. Okay, that's wrong. So we go in steps of 2 each time. X goes up by 2. We get a y increase by either 2 if we are on both numbers, or we get a y increase of minus 6, correct? Yeah, minus 6. So this function is actually pretty simple. It should be f of x equals minus 3 times x, I think. Let me think about this. Minus 3 times x. Yes. So this is the idea, minus 3 times x. And we now have all the things we need to know how the function is going to react to this equation. Equals 666 equals, and 666 is even, so we have minus 3 times x as the function equation that we have to solve. We solve this by dividing by minus 3 on both sides, and this x would equal minus 222. Let's try this out. Minus... okay, yeah, I do... okay. How do you do the minus? 222. I know that you can... okay, minus 222. Okay, yep. And we've solved it. This is the last level for today. I'm going to do more of this one. Level 10. Yeah, let's try it. 0. Okay. 17.7777 period, probably. Let's go for 2. No, let's first off go for 1. Okay. Also a minus in front of this. Minus 17.2 period. I have a hiccup, sorry. Okay. We have an increase or a decrease of 5/9 when going down 1. So I am expecting, this is the first assumption, that this is going to be a minus 16.7777 and so on. Which is probably wrong, because that wouldn't really get us to solve this problem. God damn it, I was correct. I mean, no, I wasn't. Okay, this is 6. Okay. Okay. So from here to here, well, how did I do this? I do need to make this symbol again. I just had the correct symbol. Why do I not have it anymore? Okay, we're going to do this. From here to here, we have a decrease. Do we have a decrease? We have an increase of plus 5/9 as a 5/9. I think 5/9 equaling 0. This number, period. And from here to here, we need to make this a little bigger. Okay. From here to here, we get an increase of plus 4/9, which equals 0.444 and so on. Maybe we need bigger numbers, so for now I'm not going to do any calculating until we have a better number. So 3, we have minus 16.1111. This is again an increase of 0.5, which is why I'm confused about this specific step. Maybe I have a little bit of a brain error, but I don't think that's this. Maybe. For now we're going to think about, okay, we're going to continue for now. 4 input the number for 15 point, okay. Yeah. Honestly, I don't quite see the pattern entirely. 5 minus 15. Okay, this is, okay, 5 minus 15. Also the last one was minus 15. Okay, 0.555. Okay, I do have an idea of what this does. We're going to check out the 6, and I don't think that I can formulate this in a proper way. Yeah, 6 equals minus, okay, 14.4444. Okay, I need to go until I get a number that ends with a 0.777 and so on. So we are going to go for a 7, a 0.888. Okay, yeah, minus 13.888. 8, 8, okay, minus 13.333. We have not yet had a number that doubles itself. The next one could be a 0.999, which no, it can't, because this one was 0.999. If you don't know, if you have something that is minus 15.9999 period, it means that the thing you have equals or is around around the next whole number. So for example, 1.99999 and so on period equals 2. Because of what I am writing right here, 1/9 equals 0.1 period, and if you think about this, 1/9 times 9 equals 1, but at the same time it equals 0.999. If you use it on this representation, it equals 1, it equals 9 over 9, and on this representation it equals 0.99999 and so on. This is how multiplication works. So the only number that's still missing is a 0.76543.218. Yeah, I think now we should get a 7 again. 9. Yep, minus 12.07 period. Minus 12.7 period. I don't know how to best do this. So first of all, the next number that is going to be whole again is going to be, if I check this out, this is 3, this is 4, this is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you take a batch of 10 numbers, then 9 of them are going to be non-whole numbers. What I mean by that, my assumption is going to be that if I go for 1, 2, 3, 4, 5 more numbers to 14, the number is not going to be a whole number, and 15 is going... God damn it. So I made a small mistake by saying that. So let's just write this down. 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I understand. No, I don't understand this. This makes me... Okay, no. Okay, I understand this. The 9th number from... the 10th number from my batch of 10 numbers, it repeated. What I'm assuming is that this means that that the numbers I have are basically... I'm using them as... I'm categorizing them into 9 different categories. This is going to be the category 0, the category 1, 2, until the category 9. Until the category 8. This 9 falls into category 0. So anything that is a multiple of 9, 9 times k, is in the same category as 0, like this. And by that I mean, if I type in f of 9 times k, it should always equal something 0.7777 and so on. I can categorize it like this. And 5 is in the category of 5 times k is in the category of 5, first of all. No, it's not in the category of 5. 9 times k plus 5 is in the category of 5. What that means is any number that is 5 added on top a multiple of 9 is going to be in this category, and f of this number, 9 times k plus 5, equals a whole number. While a whole number. So I need to find what is the increase of those numbers. The increase is by -5. It's not a good increase. What happens if we type in 10? I'm curious. Or I think I already know that. Yeah, 10 should be 7. Okay. Yeah, first of all, we're going to increase this by multiples of 9 plus 5. Let's check out 95. What does this get us? Okay, 35. How about 185? 185. I still didn't think about what the number is actually about. How about 9005? 4000, okay, that's a little high. 905. Okay, this is unbelievably annoying that I'm always typing wrong. Okay. 905, we are almost there, so we need to go for 1805 maybe. Too much. 1355. We're getting closer. Okay, I could also... Okay, I'm going to do it the correct way. F of... I'm too lazy to do this entire thing. 9 times x plus 5 equals... The closest number that we want is 665. F of 9 times... this should equal... And I have not really thought about the actual increase. What's the actual increase? What did we get when we were... Okay, I actually need to think about this. That's annoying. First of all, here the actual increase is -10, -15. So every 9x we get an increase of 5. Okay. 5x. And also, if we get this 5, I need to think. First of all, that's not quite correct. No, this is correct. We increase our thing by 5, and then the first number that solves this by x equaling 0 would be the 5, and that equals -15. So 5x minus 15. Okay. this is the function that we have to solve. First of all, 5x minus 15. So with our function that we really use is if we use f of 9x plus 5, it equals 5x minus 15. The first thing we need to do is 5x minus 15, we solve this after 660 by equating this to 65. This is the only possible number that is actually in question. If we do this, we have 5x equals 680. This would mean x equaling 100, 130, 136. So let's just say 136. 136 times 9 plus 5. We will need the calculator for this. I could try to calculate this myself, but I'm too lazy. 1229. 665, okay. So we are pretty close. I just need to find out what I should write now. I mean, I could try and think about what this actually does, but I am pretty lazy to do that. So I could just brute force this. So I'm just going to do that. 1229.1. Okay, yeah. 1229.5. No? Okay, this is a little different. I thought that I could do it like this. Okay. Point. Okay. We had a 1, we had a 6, we had a 2. No. So that's 65.277. I'm not quite sure what actually this curve does. Okay, we now actually have something that we can use. I'm going to use the graph menu because that's a lot easier than actually thinking about stuff. I'm going to go down until I actually have an idea of what the actual number is that we're multiplying by. I mean, this is probably not wrong what I did. The thing is, what is it what I'm doing wrong? So this one, this function should actually be correct, but I just don't know what mistake I'm making. I don't know. For now, we're going to go down a lot more. The idea is that I want to check out this plot at 0. Okay. What is this plot at 0? Can I somehow... Okay. So first of all, 0, 1. Those are bad numbers, I can't work with them. Okay. So there is a way to do this if this thing is linear. If this thing is linear, m times x plus b is the function that we can use. This looks like a linear function. For most of this stuff it looks like a linear function. I'm just not entirely convinced about this thing. It looks quite weird, but I don't know why. M times x plus b, and we know if we check out the 0 point, we actually should know what the thing should be. So if we go for 0, it should be minus 17.77 and so on. I'm going to write this as minus 17 minus 7 over 9. What is 17 in x over 9? This is minus plus 7, 90, 63, 153 plus 7 over 9. This should equal minus 160 over 9. So we would have m times x plus minus 160 over 9. That should be all b. But our x we need to figure out. It's probably going to be the thing that we did last time. So m of 5, m times 5m minus 160 over 9 equals, what was it again, minus 15, I think. I'm doing an entirely different approach to this thing, since I did see that this was actually a graph. We have a lot of an easier time than before. So if this is a linear graph, we don't really have to think about this. I thought that this thing wasn't algebraic because I couldn't really predict the space between. I tried to think about the space between this interval. We're going up 1 on the x scale, but we're not going up a constant number on the y scale. At least that's what I thought. Apparently I made a miscalculation, I'm not quite sure. So I'm just going to do this the old-fashioned way, and I'm going to solve for x. Minus 15 in over 9 is minus, what is 15 times 9? 90, 45, 135. Okay, so 5m equals 25 over 9, I think. And that would mean m equals 5 over 9. So f of x would be 5 over 9 times x minus 160 over 9, and that equaling 660 would mean we would need to do this in over 9. Okay, that's a little annoying, but hey, we can do this. F of x equals, how do we do this? 54 plus 540 plus 5400 equals 4, 9. I'm just calculating what 606. 9 times f of x equals 9 times 606, and I'm calculating that by myself right now, if you're confused about what I'm doing right now. 4, 9, then this should be a 9, 5. Okay, 9 times f of x equals 5994. So this means 5 times x minus 160 equals 5994. This means 5 times x equals 6154, if I didn't miscalculate. We can calculate again in case something happens, but for now I'm going to think this is correct. 1230.8, and we're going to try typing this in. Okay, 1230.8. Okay, we got it. And level 11 we're going to do on a different day. This was long enough. I like this game and I'm going to be playing it. So have a nice day and goodbye.